Hello everyone, myself Dr. Ashalata KS. Now we shall discuss increasing and decreasing functions. Increasing and decreasing functions. Let y equal to f of x be a given function defined in the interval closed interval a comma b. Let delta x and delta y be the increments of x and y respectively. Then dy by dx is given by limit delta x tends to 0 delta y by delta x. The sign of dy by dx depends on the sign of delta y by delta x. Let the increment delta x in x be positive. Then the sign of dy by dx is positive or negative. Now we shall consider two cases here. First case, let delta y be positive. That is delta y greater than 0, which implies y plus delta y greater than y, which in turn implies f of x plus delta x is greater than f of x. Therefore, delta x is positive, which implies delta y by dy by dx is positive, that is greater than 0. That means f dash of x is greater than 0. Hence, a function y equal to f of x whose derivatives exist in the interval a comma b is an increasing function in the interval if and only if f dash of x is greater than 0 for all x belongs to a comma b. The function is said to be increasing if f dash of x is greater than 0. Case 2. Let delta y be negative, that is delta y less than 0, which implies y plus delta y is less than 0. That means f of x plus delta x is less than f of x. Therefore, f delta x is positive, which implies dy by dx is negative, is less than 0. That is f dash of x less than 0. Hence, the function y equal to f of x whose derivatives exist in the interval a comma b and is in decreasing function in the interval if and only if f dash of x is less than 0 for all x belongs to a comma b. When the curve is increasing, that means f dash of x is greater than 0, geometrically the slope of the tangent is positive so that the inclination of the tangent to the x-axis is acute angle. Similarly, when the curve is decreasing, that is f dash of x is less than 0, geometrically the slope of the tangent is negative so that the inclination of the tangent to x-axis is obtuse angle. Here are some important points. For a continuous curve, when f dash of x changes its sign from positive to negative, it becomes 0 at some point on the curve. That is, f dash of x equal to 0. At this point, the curve is neither increasing nor decreasing. Such a point is called stationary point on the curve. The second point, the tangent at the stationary point is always parallel to x-axis. We shall solve some problems on this increasing and decreasing function. First one, show that the function f of x equal to x cube minus 6x square plus 12x minus 16 is increasing function for all x. So consider the given function. Now differentiate the given function with respect to x, that is f dash of x equal to 3x square minus 12x plus 12. Okay, that is equal to, further simplify this, you can take 3 common, x square minus 4x plus 4. Now the terms inside the bracket can be written as x minus 2 whole square, a square minus 2ab plus b square formula. So now this x minus 2 whole square is a perfect square which is always positive. Therefore, f dash of x is always greater than 0 for all x. Hence, the function f of x is increasing function for all x. Next problem. Find the range of values of x for which the function f of x equal to 2x cube minus 15x square minus 84x plus 7 plus 5 is decreasing. We have to find the range values of x for which this function f of x is decreasing. That means f dash of x is less than 0. So first of all, find out f dash of x. Okay, so what is f dash of x? Differentiate this with respect to x. You will get 6x square minus 30x minus 84. Now take 6 common, it will be x square minus 5x minus 14. Now find out the factors for this quadratic equation. It is x plus 2 into x minus 7. Okay. So since you have to find out the range for decreasing function, so f dash of x must be less than 0. So f dash of x is 6 into x plus 2 into x minus 1, x minus 7, which is less than 0. So this must be less than 0, means either x plus 2 less than 0 or x minus 7 less than 0. Which implies if you transfer this 2 to LHS, you will get x less than minus 2 and this will be x less than 7. So f dash of x less than 0 for the values of x between minus 2 and 7. For this range, the function f of x is decreasing function. Next problem. For what values of x the function f of x equal to x to the power of minus x to the power of 4 minus 2x cube plus 1 is increasing. So that means f dash of x is greater than 0. Okay. So find the derivative of this function. It is 2x square into 2x minus 3. So now we have to find out the range for which the function is increasing. That means this must be greater than 0. So this is greater than 0 means x is greater than 0 or 2x minus 3 must be greater than 0, which implies, this implies x is greater than 3 by 2. So for all values of x greater than 3 by 2, the function f of x is increasing function. Separate the interval in which the function f of x equal to 2x cube minus 15x square plus 36x minus 7 for all x belongs to R is decreasing or increasing. Okay. Consider the function, differentiate with respect to x. Now after differentiating, find out the factors for this. For increasing function, we have f dash of x is greater than 0, which lies between minus infinity to 2 and 3 to infinity. For f dash of x less than 0, that means x minus 2 less than 0 or x minus 3 less than 0, the function is decreasing in the interval 2,